Hello everyone. Today we are going to see about clustering in data mining. A cluster is nothing but a collection of similar data which is grouped together. The main advantage of clustering over classification is that it is adaptable to changes. It is an unsupervised machine learning based method. Now let's see clustering in data mining. Clustering. A collection of data objects that is similar to one another within the same group is known as cluster. At the same time, dissimilar to the objects in other groups. This is known as clustering in data mining. So if we talk about raw data, similar objects are formed into clusters. So what are the applications of clustering? It is mainly used in biology, that is taxonomy of living things like kingdom, class, order, family and species. It is used in information retrieval, that is document clustering. Then it is used in identification of area of similar land use in an earth observation database. Clustering is mainly used in marketing. It helps the marketers to discover distinct groups in their customer base. City planning, identifying group of houses according to their house type, value and geographical location. Earthquake studies. Observed earthquake epicenters should be clustered along continent faults. That is, we can identify earthquake areas using clusters. The next one is climate. Understanding earth climate, find patterns of atmospheric and ocean. The last one is economic science. That is, it is used in market research. So these are the application of clustering. So when we talk about clustering, we should know the challenges in clustering. The first one is scalability. Clustering all data instead of only on sample is a main disadvantage in clustering. The second one is ability to deal with different types of attributes. We are using so many data types like numerical, binary, categorical, ordinary, linked and mixture of these. So this is a problem in clustering. Constraint based clustering. User may give inputs on constraints. At the same time, the domain knowledge to determine input parameters is also a challenge in clustering. Interpretability and usability is a main challenge in clustering. Then the others are discovery of clusters with arbitrary shape, ability to deal with noisy data, incremental clustering and insensitivity to input order. Then the high dimensionality is a main challenge in clustering. Now let's see major clustering approaches. There are 4 types of approaches in clustering. The first one is partitioning approach. Construct various partitions and then evaluate them by some criterion. Example, k-mean, k-medoid and Clorentz. Hierarchical approach. Create a hierarchical decomposition of the set of data using some criterion. Example, Diana, Agnes, Birch and Chameleon. Density based approach. Based on connectivity and density functions. Example, DBScan, Optics and DenClue. Grid based approach. Based on multiple level granularity structure. Example, Sting, Wave Cluster and Click. Now let's see the k-mean clustering algorithm. It is based on partition. K-mean clustering is an unsupervised machine learning algorithm that is used to solve clustering problems in machine learning or data science. The k-mean clustering algorithm mainly performs 2 tasks. One is determines the best value of k center points or centroid by an iterative process. The second one is it assigns each data point to its closest k center. Those data points which are near to the particular k center create a cluster. So this is the picture which depicts k-mean clustering algorithm. This is the left side is before clustering and the right side is after clustering using k-mean algorithm. Now let's see the algorithm. Input k, the number of clusters, and D, a data set containing n objects, and the output is a set of k clusters. So how it functions? First step, arbitrarily choose k objects from D as the initial cluster center. Then it will continuously reassign all the object to the cluster to which the object is the most similar based on the mean value of the objects in the cluster. The next one, update the cluster mean, calculate the mean value of the objects for each cluster. It will continuously repeated until there is no changes. Now let's see k-mean algorithm with an example. We are having 8 points. We are going to form 3 clusters. So we have 8 points, that is A1, A2, A3, A4 and A8. So we arbitrarily choose 3 points like A1, A4 and A7 as cluster centers. So we are taking A1, A4 and A7. So we are going to find the distance between 2 points, that is, so we are going to calculate the distance between A1 and A2, A1 and A3, A1 and A4, A1 and A5, A1 and A6, A1 and A7, A1 and A8. Likewise, the second step, we are going to find the distance between A4 and A1, A4 and A2, A4 and A3, A4 and A5, A4 and A6, A4 and A7 and A4 and A8. And the third step, we are going to find the distance between A7 and A1, A7 and A2, A7 and A3, A7 and A4, etc. This is how we are going to calculate the distance. The first cluster, we are going to find the distance, the second cluster and the third cluster. Now you will get these kind of results. That is the distance between A1 and A1, distance between A1 and A2, distance between A1 and A3. Likewise, the distance between A4 and A1, A4 and A2, A4 and A3. Likewise, we are going to find the distance between A7 and A1, A7 and A2. So this will be marked here. So the distance using the formula, this one, that is modulus of x2 minus x1 plus y2 minus y1. This is the formula we are using to find the distance. Right? So, in the right side, you are seeing something, right? So, here we are having some distance. We are going to mark which distance is near to the cluster 1 or 2 or 3. So, first one, 0. 0 is near to cluster 1. So, we are marking the point as C1. That is, the point is belonging to cluster 1. The next one, let's see, 5, 6, 4. So, this point is near to cluster 3. So, we are marking this point as C3. That is, this point is near to cluster 3. Now, the third row, 12, 7, 9. So, here, 7 is near to cluster 2. So, we are marking the A3 point as C2. Likewise, we are forming 3 clusters with this one. Like, first cluster with only 1 point, A1 with 2, 10. The second cluster is with 1, 2, 3, 4, 5 points. And the third cluster with 2 points. So, this is first iteration. We have to perform next iteration to find the cluster mean. The next step is, for the first cluster, we have to find the mean of that particular cluster using this one. That is, first cluster is having only 1 point, so there is no mean for it. The second cluster we are going to find, that is, adding all the x value divided by 5 and adding all the y point divided by 5. So, it will give the mean value for your cluster 2. Then the cluster 3, we are having 2 points. So, first we are adding the x coordinates, then adding y coordinates, then dividing by 2 will give you the mean. So, we are now change the mean value of each clusters. We are getting 3 different mean values for different clusters. So, the first cluster's mean value is 2, 10. The second one is 6, 6 and the third one is 1.5, 3.5. Now, what you have to do is, again we are going to calculate the distance between each points. That is, now this cluster center for the first point is 2, 10. So you have to find the distance between this point 2, 10 to A1, 2, 10 to A2, 2, 10 to A3 likewise. You have to find the mean value of the cluster 2 and find the distance between 6, 6 to A1, 6, 6 to A2 likewise. So you will get another table with the distances. In the second iteration, we have calculated the mean value of each cluster and the distance between the cluster midpoint to each points, that is A1, A2, etc. Now we have calculated the distance from the point to the cluster center. In the first row, we have the values like 0, 8, 7. So 0 is near to cluster 1. So we have marked the point as C1. That is the point A1 is near to cluster 1. The second row 5, 5, 2. So the A2 point is near to cluster 3. So we have marked A2 point as C3. In the third row 12, 4, 7. So the minimum distance here is 4. So every time we have to take the minimum distance and attach the particular point to the particular cluster. So here the point A3 is near to cluster 2. So we have marked the cluster as C2. Likewise, we have to find the distance between the cluster center and the point. Then we have to form the cluster according to the distance. This is how the K-mean algorithm works. Now let's see the K-mean algorithm once again. So first, arbitrarily choose K objects from D as the initial cluster center. We have taken A1, A4 and A7. Repeat, reassign all objects to the cluster to which the object is the most similar based on the mean value of the object in the cluster. So we have calculated the distance and attached to the particular cluster. We have updated the cluster mean and calculated the mean value of the objects for each cluster. Then we have iterated the above step. So this is how K-mean algorithm works. Hope you have enjoyed the session. Thank you.